Hello, welcome to our webinar, Benefits Appearing for AI Workloads. I'm Bill Sigmund, Director of Sales Engineering at phoenixNAP. Today, our guest is Brandon Ross with DE-CIX. Say hi, Brandon.
Hi, Brandon. It's good to be here.
All right, let's go ahead and get started. I'd like to start off with a couple of poll questions real quick so we can tailor it to you guys. The first poll, obviously, is what kind of IT infrastructure are you using for your AI workloads? And these are folks, we're looking for the folks that are doing public, private, or multi-cloud, or just straight on-prem. So we'll pause for a moment and let you guys answer. Yep, about what I thought. So it looks like obviously multi-cloud and hybrid are the number one go-tos, and then we've got a mix of the others. For the next question, what would you consider to be the top challenge of your AI workloads? Yep, and again, that's pretty much what we find out there in the field as well. One last question, if you don't mind. Does your organization use peering today? And it looks like we have an even split between the yeses and the nos, so it's about 50-50. That's good. So let's jump on in. Obviously AI is getting huge right now. As everybody's trying to adopt AI, obviously performance is number one, right? I mean, that's why we're having problems getting RAM and hard drives right now. The market is poised at 2.4 trillion by 2032. We're seeing crazy investments out there, but however, as you guys probably know, there's a lack of maturity in the space, a lack of standards in the space. So we do expect it to consolidate later on down the road. But that also makes IT guys have a few problems. And as you see here by these stats, which kind of line up with what we did on our polling questions, performance obviously is the biggest thing, and IT infrastructure obviously. Moving forward. So, as we saw in our poll here, it's mostly hybrid, right? Some folks have a mix, most folks have a mix, but people just don't understand how they can future-proof everything. So we're seeing out there, obviously on-prem and cloud, and a mix of just public cloud folks out there. There's very few, mostly on-prem. Confidence is not very good out there right now, obviously, as things are changing so quickly. So that's making folks nervous. On the top performance challenges we're seeing with customers, obviously grabbing enough compute. Again, that shows right now with trying to get RAM and drive space out there. Constraints from the software are a big problem too, but surprisingly, network comes in second every time people talk about it, which is why we're here to talk about peering. And then of course, storage as well. Latency and availability are at the top. As we talked about earlier, most people think it's at least important. And that's why we're going to have Brandon on here in a moment, right here. Brandon, take it away, sir.
I shall. And so I'm sure that most folks at this point, especially in our technical disciplines, are pretty familiar with the two different stages of AI, but it's important to talk about them a little bit, just so that we can better understand their requirements on our infrastructure. So of course, there's the AI training stage. This is of course when we take all this data that can be scattered all over the world or wherever we're storing it and use computing resources, generally GPUs, to ingest that data and create and maintain and update our AI models. And then, of course, the second stage is the inference stage, right? The inference stage is when we use a device or the internet or something like that to connect to a large language model, to an AI model, and ask it questions or have it do tasks for us, right? And these two stages have very different profiles. So next slide, please. Bill, next slide, please.
It's not showing for you? Yeah.
There we go. It just did. Maybe there's a little bit of latency. So let's talk about latency, right? We just had a good example of that, and potentially part of the reason that the slide was slow for me and latency was a problem is I'm actually in a house in rural West Virginia right now. I'm visiting some family while I do this webinar, and so the latency here is potentially, although I haven't looked deeply, the network is potentially higher than it would be if I was in a big city. It certainly would be higher if I was queuing on an internet exchange. And so let's go back to the slides here. And so talking about AI training, right? This data could be anywhere in the world. How fast we get that data into the model is really not a big issue. So latency when you're doing the training stage of AI is not a big deal. We have this little neat little slider chart here on the right side of the graph here showing that. But bandwidth, of course, is extremely important, right? These data sets tend to be enormous and have to be enormous in order to train a large language model in a useful way. And so when we're looking at that, we want to make sure we're optimizing our infrastructure on the training side for the amount of bandwidth available. And if you go to the next slide, please, we'll see how long it takes this time.
It's done
to show up for me. All right. Well, if everyone else sees it, I'll start talking to it because I know what it says. So we have the AI inference triangle, right? Where we're training this AI model, well, I'm sorry, the inference model where we're using this AI model using our devices. And so when we're using the model, either humans are interacting with the model or it could be an automated interaction with the model. But either way, if you can imagine a task that has a lot of back and forth and that has a large dependency on quick reaction. So the typical example that folks use in the market is like robotic surgery, right? If you're doing robotic surgery or AI driving a vehicle or anything in real time, you're going to need that back and forth of query and response to the AI model to be very fast. And so latency is extremely important when we're talking about the inference side of AI. While the amount of bandwidth, while there's certainly some bandwidth intensive applications out there, especially if you're creating video or working with large images or such, but for the most part, most AI interactions are low bandwidth, right? You're asking a question, you're getting a text response or maybe a table or even a graphic, but you're not really usually looking for a whole lot of bandwidth necessarily. And so again, on our little slider to the right, you know, our sensitivity is turned up way high when it comes to latency, but when it comes to bandwidth, maybe it's not so important for various particular applications. Now let's talk about how this works with peering. If we could go to the next slide, please. So for those of you on the call, looked like a 22%. We're not sure if you're peering, or maybe you're not sure what peering is. Peering is when you connect your network directly with some other network and exchange traffic. Now that's different from internet transit, which you might call as dedicated internet services or dedicated internet access to a lot of places, where you're buying a pipe to the internet and your upstream provider is handling getting all your traffic to various destinations. Instead, when we're talking about peering, we're talking about a direct connect. So for example, if you were buying transit, you might be buying transit from your local cable company or maybe your local telephone company, and then they have to get that traffic to, say, Google, or they have to get that traffic to another eyeball network, like another cable company. So you're going through this other network, which means all these extra steps, all these extra hops throughout the network. When we're peering, we peer directly. And so there's two kind of models for how that peering can work. Conventionally, private peering means you're creating a full mesh because you're going to want to connect your network directly to every other network that you're interested in sending traffic to or receiving traffic from. Obviously, that is a scalability nightmare because anytime you get involved in creating a full mesh of anything, it means that you're growing your need to maintain it in an exponential fashion. And so what the marketplace has done and what we've done at DE-CIX is we've created an infrastructure such that you can exchange with what we call an internet exchange point, which often is abbreviated as IXP or just IX. And an internet exchange point, this exchange point operator operates usually a layer 2 network fabric that allows a lot of different networks to connect into that fabric and then have direct access to all of the other networks connected to that fabric. Again, that's our how we gain and attain scalability, and how we allow a bunch of different networks to talk to each other without having to build unique relationships with every other network that's possibly out there that we want to exchange traffic to. So I'm talking a little bit about how peering enables and enhances AI performance. So we're already back to that original stage, right? If you think about what we were just talking about, by cutting out all of these extra hops that a transit provider introduces into your network, we gain a lot of benefits. So let's talk first about security and control of your traffic. Obviously, the fewer and shorter distances your traffic travels, the improved security posture your organization is in. If I have to go and trust 2, 3, 4 organizations that my data travels through to all be secure, that is less secure than only having to trust my own organization and the peer organization that I'm exchanging that traffic with. Again, that could be a PNI, that could be a private network interconnect, or that could be across a internet exchange. But either way, you're gaining a lot of security and control over that traffic. Increased route control is another way that both enhances security and performance in a way. By being able to control where my traffic goes, I can better enhance my security. I can better have controls in place to also observe that traffic and ensure that it's following a path that's staying within organizations that I trust. And then, of course, we're getting a performance boost as well. Again, cutting out all those extra links and all of that out of the path makes a big difference. And it's not just the links themselves, right? Any time that you go through another provider, you're going to add geographical distance, most likely, to the path that your traffic takes. So if you've ever done a trace route from, say, your home to your work or something like that, you might find that your traffic goes through a distant city in order to get to the destination you're trying to get to. And that's because when you build a large transit provider, often you're having to make compromises about how you aggregate that traffic and where that traffic has to go between providers. But if you peer at an exchange point that's local to your geography, then you cut out all that geography. But you also cut out all those extra router hops, all those extra links between the routers, and all of that contributes to improving security. So this also enhances the resilience of our traffic, right? If we're cutting out hops across the network, every hop has some percentage chance of failing at any particular time. So by removing steps in the network, we're improving our reliability. But we also improve our resilience because now we have multiple ways that we can connect to these multiple networks. I'm not suggesting anyone on this call to just cancel your transit contract and never buy transit again and only peer. That would be nearly impossible. But by adding peering to an existing ecosystem of traffic exchange in your network, you have another path. So if I'm peering with my content provider, I'm able to primarily get to my content provider over the peering, but if for some reason that link went down, I can still access my content provider over my transit link. And so I have built-in resiliency and redundancy between those connections by doing so. You also get more paths out of it. If you peer in multiple locations, then you have even more resiliency and more redundancy in your network that can save you during an outage, and also maintain performance across those outage situations as well. And then cost effectiveness is probably top of mind for most people in just about everything we do, right? The boss is always asking how we're going to save some money. So peering tends to be dramatically less expensive than buying transit. When you peer, almost every peering exchange I'm aware of, you buy the port, you pay for the port, you pay for a certain amount of access to that network, but you don't pay per the bit. You don't pay by how much traffic you actually use across that network. There could be exceptions out there, but certainly here at DE-CIX, we do not charge for traffic. We only charge for access. So you're going to see your bill go down. You're going to send less traffic to transit. Transit almost always charges on a 95th percentile billing, which means you're paying based on how much bandwidth you use, not just the access to the network. And we go to my final slide in this presentation is a little bit about DE-CIX and where we are at. We have 60 exchanges around the world, including a whole bunch here in North America and a bunch in the US, depending on where in the world you are listening to our presentation from. And most importantly, we have an exchange in Phoenix, right at our partners here. We also have access to over 50 cloud service providers across our network. So when you are building your AI infrastructure, you are probably going to be using a lot of cloud computing, whether that's for ingestion of data into and building that model, or whether that's inference, whether that's accessing a cloud service provider that is hosting an AI model for you. Either way, we have access to all of those cloud service providers already in our exchanges in a lot of places. And so when you join our exchange, you're able to exchange traffic directly with the compute resources that are maintaining those. We're also at thousands of data centers around the world. There's a great chance that your infrastructure is in the same data center as ours. And if that's the case, it means it's just a cross connect to get from your network to our network. And then from our network, of course, you then have access to all these other 4,000 plus connected networks around the world. You're covering multiple continents and multiple areas. If you have operations in Europe, Asia, or even Africa, we probably have an exchange point that's not too far from you. And again, the closer the exchange point is, the lower we'll get that latency and the better performance you're going to get across your network. And at this point, I believe I'll hand it back to you, Bill.
Sounds good. Thank you, sir. Before we continue, I want to remind everybody, if you go in the GoToWebinar control panel, you'll see a questions link inside of there. If you have any questions, please feel free, drop those in there. We'll get those answered for you at the end of the session. Talking about Phoenix now. So obviously it's an enterprise grade data center. Every year we go through compliances with SOC 1, SOC 2, PCI DSS, HIPAA, and we are AZ ramp certified as well. We do GDPR as well because we do a lot of business overseas. So know it's there. We're tier 3 plus. We do complete customization. If folks want to park their gear there, that's fine. We can offer quarter cabinets all the way up to giant private cages with as much power as you need. We have 24/7 NOC and SOC there. That is all normal inside of Phoenix. We don't outsource that stuff, just so you guys know. So you're talking to English speaking folks every time you call us or email us. We do have 2 meet me rooms, which is where you'd find DE-CIX. They got redundant fiber vaults into them. 40 plus carriers. We are the carrier for the Southwest, basically, where everybody comes in. So chances are, if you've got a carrier, we've got them in there. So it'd just be a direct connect, as Brendan already mentioned. So the other thing I want to mention is we do have AWS, Google Cloud, and Microsoft Azure on-ramps in there as well. We're doing a data center expansion right now. So the first floor expansion is just completed. We needed the space for our flagship bare metal cloud product. So we do have other space available for folks as well. And again, as I mentioned before, first and second floor, both data halls have the ability to connect into the hyperscalers with their on-ramps. I don't want to talk too much about this because this is going to bore everybody that's not an electrician. But we've got 530,000 square feet of data center space, 30 megawatts A and B side, 4 network vaults, obviously. That's about all we have to say about that. At this point, let's go to Q&A, see what we've got for questions. The first question is, what's the waiting period for colo space in the first floor expansion? That space is ready for migration now. There's no pre-leasing required. It has power, cooling, connectivity, everything all in there, including access to the hyperscalers, as I mentioned before. Question 2 is, in reference to the 19% storage stat on the top performance challenges, how does the 41% of orders want to upgrade storage system stat compare with other upgrade plans? Good question. So 60% consider security top, 50% consider compute, as we talked about earlier, they're trying to get infrastructure in place, and 37% consider network bandwidth and latency top priorities. Third question, Brandon, this one's probably for you. If my data set that I want to train my agent on is in Azure, what's the best way to move it from Azure to my GPU provider?
Sure thing. Well, as I mentioned, at DE-CIX, we have on-ramps to all the major cloud computing organizations, including Microsoft Azure. We have a service called MAPS, Microsoft Azure Peering Service, where you can peer directly with Microsoft across our exchanges and get access to all of Azure and a lot of other Microsoft content as well. So by buying the MAPS service, you can connect it to your own AS, into your own network, and then from your own network, you can connect it to any other cloud service provider as well. So we have a strong ability to enable multi-cloud in that way. We also have a multi-cloud router product as well that lets you basically have a virtual router that we operate that routes traffic between any number of your cloud service providers and your own AS, your own network, as much as you like. And then I believe that phoenixNAP, we also have the cloud on-ramps as well. So they also have an option of going at phoenixNAP. You also have the option of going directly to the cloud service provider. Just depends on what you're trying to accomplish.
Well, obviously with us, those on-ramps are on the west side, right? So if they need to go east, it might make more sense to go with you guys.
Yeah.
And that looks like that's it for the questions. So one last poll, guys, if you don't mind, please take a moment to answer. Would you like to get in touch with phoenixNAP or DE-CIX?
And while you're answering that question, I could also mention that one thing that comes along with DE-CIX services is my time as a peering consultant to help you design and connect with other networks. And you don't necessarily have to be a DE-CIX customer, or it doesn't have to necessarily involve DE-CIX products. So it's one of the extra benefits we offer as a part of the peering ecosystem in the world. We like to help drive additional interconnection, and we're always happy to help, whether you're a customer or not.
All right, thanks, sir. And with that, guys, we appreciate your time. Thank you very much for considering us, and have a great day.
Thank you, everybody.